Let us now see how in thermodynamic we visualize a state. Let us take an illustration. Let us say that we have a cylinder and it contains a gas. It could be gas used for cooking, it could be some gas used for welding, it could be oxygen used in a hospital. Let us say that the relevant properties are pressure of the gas in the cylinder, temperature of the gas in the cylinder, and mass of the gas. And let us say that since it is a rigid cylinder, volume is unlikely to change, and hence we will not consider volume to be a significant variable or a relevant variable, at least to begin with. And let us say that we have done measurements and said that after our measurement the pressure has been measured to be 20 bar, temperature has been measured to be 14 degrees C, and mass has been measured to be 20 kg, and our system is this gas. One way of noting this down is our system and its state is gas, list of properties, quantification of property. So P is 20 bar, T is 14 degrees C, and mass is 20 kg. Although this is the written description, notice the similarity of this. Now look at it from the point of view of coordinate geometry. Remember that there are three properties, so we could consider three dimensions. Isn't this equivalent to saying that we have a point in three-dimensional space represented by x equals 20, y equals 14, z equals 20. Point in space. And actually we can use this analogy to represent our system in three-dimensional space. We can nicely sketch the three dimensions like this. Let us say here we represent pressure, here we will represent mass, and here we will represent temperature. The pressure is pressure in bar and our pressure is 20 bar. Mass, our mass is 20 kg. Temperature is 14 degrees C. So these are the three coordinates, and using these three coordinates we can now locate our point in the three-dimensional space. Create a rectangular parallelepiped. So we will have our point somewhere here. This point represents pressure of 20 bar, mass of 20 kg, temperature of 14 degrees C. This will be a representation of the state of our system. Now remember that this is something like, in this particular case, because there are three properties, three-dimensional geometry. The pressure is represented on one axis, the mass is represented on another axis, and temperature is represented on the third axis. So each coordinate represents a property. So first thing we should realize is each property is represented by a coordinate. Then the geometric space will represent the thermodynamic space, and what is represented is the state of our system. So one should remember and appreciate the analogy between the geometric space and the thermodynamic space. This is known as thermodynamic state space. In the thermodynamic state space, each coordinate, in this particular case pressure, mass and temperature, represents one thermodynamic property. A state is represented by specified values of that property. In this particular case, pressure of 20 bar, mass of 20 kg and temperature of 14 degrees C. Thank you.